So this guy Nadal, pretty good tennis player. Average serves about $1.15, depending on how he's feeling, I guess. And then the standard deviation 6 miles per hour. So this is the distribution, and I just drew the normal curve, right? Hopefully you guys are really good at drawing those by now. This is the distribution. The only two things you need to know are the mean and the standard deviation. So let's label it then with the capital N parentheses notation. So 115, comma 6, right? Mean, comma standard deviation. Over here, that's days when he's feeling really, really good. He's just bringing the heat. He's serving about $1.20. Then down here, he's just had a long day. Wimbledon's really wearing on him. Anyway, it's Nadal. So what proportion of his serves would you expect to go slower than a 103? He's having a pretty rough day. So let's mark off the mean. Right in the middle, let's put the mean down on this distribution. So right in the middle, I'm going to hit, I got it, don't worry. Computer went to sleep. So mean is 115. And then I don't know where 103 is. I'm assuming it's somewhere to the left. In fact, we know it's somewhere to the left, right? But then let's, somewhere to the left here, put 103 down. I'm going to label both of these miles per hour. What's special about 103, by the way? Yeah, it's 2 standard deviations away. 2 standard deviations below the mean, right? So to find this proportion, we need to know the z-score for 103, and I'll kind of just go straight up here, this boundary, everything below that. He's having a bad day, so all this stuff. So what's the z-score for 103? Well, actually, you don't even need to do any math to find that. If you heard what we just said, right? So what's the z-score? What's the z-score? Anybody know? What, Kayla? It's got to be -2, right? Without doing any math, it's got to be -2, because that's what the definition of a z-score is. How many standard deviations below the mean? But just to be thorough, we'll do the math. So 103, take that, subtract the mean, which was 115, divide by standard deviation, which is 6. So -12 over 6. -2. So what is that proportion? Less than -2, the z-score. Because that's what's going to be for him, and it serves at 103. Yeah. So that's where you look up -2 for the z-score, and then find 0.0228 on the inside. So in context, what does 0.0228 mean? Isn't that green area that we shaded? 0.0228? Nathaniel, you know?
It's the proportion of his serves below 103 miles per hour.
Exactly. So I'm going to say about 2.28% of serves below 103. Yeah, that's how you answer in context. What does it mean in terms of the problem? So part B, what proportions of his serves would you expect to exceed 120? So he's having a really good day. He's really bringing the heat. He's over 120 miles per hour. What proportion would you expect? So I got my labels, and I'll mark off where I think 120 is at, up above the mean there. So it's probably not too far. I probably marked it way too far there. Let's say 120. probably too far still, but I'm going to leave it there for now because I don't have enough room to write. 120 miles per hour. So let's shade above this thing. And then what's that proportion? Proportion of stuff better than 120. So here's the deal, is like if you look up the z-score for 120, I think that only tells you the stuff to the left. Matter of fact, what is the z-score for 120? So 0.7967?
Yes.
All right, sounds good. 0.7967, that's the z-score for 120. So if you go to the chart and you look up 0.7967 for the z-score, or 0.80, whichever one it is, that will only give you the stuff to the left. So in purple here, that will only give you this. Because the table only reads values to the left. So if you want to know the proportion less than that z-score, what's the trick? Anybody know the trick? You subtract it from 1. Yeah, because if it's just going to give you the stuff to the left, if it's going to give you all this, and you want to know what's left over, just do 1 minus that purple stuff. Because if you add up everything in the curve, that's 100%. So 1 minus that purple stuff will be in business, right? Good. So I just got to do 1 minus this proportion. Whoops, this is supposed to be greater than right here. I want the stuff greater than that. So I do 1 minus the stuff less than that. Get there, it's 1 minus what?
1 minus 7.7967. Was that correct? Or no?
Well, I thought 0.7967 was our z-score. Was that not our z-score?
Yeah. What was it?
I don't know. What was our z-score for that? Oh, the z-score was 0.83? That's going to change things. The z-score is supposed to be 0.83. You guys get that? 0.83 for the z-score? That's okay. Don't worry about it. That's why I got an eraser for it. Yeah, don't sweat it. The percentage is actually correct. The z-score is 0.83. That's all right, buddy. Don't worry. I got an eraser for that. 0.83, and then it's 0.967 was the actual percentage. That's okay. My bad. I should remember that from last hour. 0.7967. And so Nathaniel said, 20 what?
2033.
Good, 2033.
Where is the 0.83 coming from?
That's the z-score. 0.833 or 0.83 is the z-score. So that's what you looked up on the table to get that 0.7967.
Oh, okay. All right.
Is that okay? Everybody follow that? I had 0.976 before. I want z-score. So in terms of the problem, I can add it up here to the top right, I guess. What does that mean? So 0.20, we'll say about 20.3% of serves exceed $1.20, right? Exceed. So that's what it actually means. A little box around the answer there. So this curve is the same one, normal, 115, 6. The mean's right in the middle. So how about proportion of serves in that little interval there, between 100 and 110? So So both of those are less than the mean, right? So let's say I use green for those. Between 100 and 110. Draw it straight up. Those are my boundaries. And I'm going to shade. I want to know what this proportion is, this interval right here. I think the interval is maybe the hard one. Maybe the interval is the hard one. Start with this idea. I want to know the proportion of serves between 100 and 110. So I'm going to put serves right here. Here goes serves. Between 100 and 110. Isn't that what I want to find? That's kind of sloppy, I know, my bad. Proportion of serves between 100 and 110, right? Well, I just need to know what the z-scores are for 100 and 110. That would help me out a lot. So what are the z-scores for those? How about the z for 110? So take 110, subtract the mean from it, and divide by standard deviation. What are we talking? Is it like negative 0.83? So take 110, subtract the mean, divide by standard deviation. It's negative 0.83? All right. So the z-score for 110 is negative 0.83. That means it's 0.83 standard deviations below the mean. All right, what about the z-score for the other one, for 100? So take 100, subtract the mean. Sorry, Colin, what do you got? Yeah, that's right, negative 2.5. So you got two z-scores. Now you can use the normal table. You want to know what the proportion of z-scores are between those two. So I'll write it in purple. So that proportion of serves thing, now we're going to write it like this. Proportion of z-scores between negative 2.5 and negative 0.83. That's what we're going to find.
I have a question, Mr. Bishop.
Yeah.
Why is there such a stark difference between the z-scores of 110 and 100?
Depends on standard deviation. So 110 and 100. The standard deviation is 6, right? So there's a difference of 10 between 110 and 100. So there's almost 1.5 standard deviations, or almost 2 standard deviations, in fact. Okay, so here's the idea. It's weird, I know. Intervals are weird. Why don't you find the stuff less than 110? So why don't we find the proportion of z's that are less than negative 0.83? Let's start there with the upper boundary. And I'll shade that in purple. Why don't we find all the stuff less than 110? Good. So I just covered everything in purple. Everything less than 110. So the z-score is negative 0.83. I don't know what that is. I think it's like, how much? 0.203? Oh yeah, we did one a little bit ago. So that's actually 0.203. And then let's just subtract all the stuff less than 100. So all this stuff, let me make this smaller. All the stuff less than 100 we can subtract. It looked like I deleted the curve there. You see what I'm saying? Delete the stuff less than 100. So let me just undo all these real quick. So this was 0.203, I just had that down. And now if you delete the stuff less than 100, we'll be left with this little green interval. Does that make sense? So subtract away from this the proportion of stuff less than 100. And that's like a 1% or something. What is that? Oh, wait, not less than 100. What's the z-score for 100? I already got that. Negative 2.5. Point zero what? 0.0062? Wow, okay. It's not very big. Okay. So for a grand total of the stuff in that green interval, which is 0.1968? 0.1968. Questions so far? Answered in context, 90.68% of serves are between 100 and 110. Let's move on. So part D, I already got the curve drawn. I'm sure you're pros at drawing that curve by now. What about the fastest 30% of his serves? The fastest 30%. So let's label the mean and standard deviation. Means 115. Label the curve. It's normal. 115, comma 6. Beautiful. Upper 30%. I don't know. I don't know. Maybe it's like 125 miles per hour. Who knows, right? I don't think it's that fast actually. Did it last hour. But at least I can shade. Like let's shade like what the upper 30% looks like. So somewhere. Like here, maybe? Looks like this would be like 30%. We would shade this. So they go at least what speed? What's the speed that goes with that boundary? So what's this speed? So how do you start with that? Do you find 0.3 or do you find something else?
Oh, 0.7.
Yeah, it's actually 0.7 you should look for on the chart. So if you look on the inside of the chart, if you can find 0.7, that'll give you the stuff to the left of it, right? Because the chart only reads to the left. So if you want to know what's like the upper 30%, that's in the 70th percentile. So look for 0.7 on the inside of the chart. Look at the percentages and find 0.7. Yeah, it is. And then it's like, so I like stuck right between there. I think I used 0.525.
Why don't you just use the closest fit?
Wouldn't 0.525 be closer? Is that like intermediate value theorem or something like that? I don't know either.
But it's just funny. We could just use it like we've been using it on the much everything else. Like,
Yeah. You guys should just be able to integrate this in calc. Area under a curve. Have you guys ever done that yet?
No.
Oh, all right,
Just
you
do,
will.
like, derivative.
You will. Antiderivative. It's area under the curve. You do it. Dima, you've done this area under curve. You should take the derivative of that. Come on. I'll give you the formula for normal. I'll give you the normal distribution function. Just kidding. I can. It's kind of nasty. Yeah. Yeah.
Okay. So,
Hang on a second.
here.
I want to write this. Z-score for the 70th percentile. What's up?
Okay. So here we put 30% or did this way. We did it this way.
Because it said lower 25%. This is upper 30. Right?
Yes.
So what's the z-score there for the 70th percentile?
0.53.
0.53. Or 0.52. Which one is it?
That's what this is.
Why don't we go right in the middle? 0.525. Let's go right in the middle. 0.525. Right between 0.52 and 0.53. So you guys all okay with that? You can look up 70% on the inside of the chart and then read the z-score from it?
How are people getting 0.52?
He's going between.
I said between 0.52 and 0.53. So I just picked 0.525.
But you could just do 0.52.
You could just do 0.5. You could totally do 0.52. So now just use the z-score formula. You know almost everything you need to know. You know the mean, you know the standard deviation, you know the z-score. So let's plug that into the z-score formula. So z is 0.525 equals the individual score, we don't know that, minus the mean, divide by standard deviation. And just tell me what x is. You guys concur? 118.15? Okay, I'm good with that. So 118 miles per hour. So, in context though, here's how you should answer it. Nadal's fastest 30% of serves go at least that, 118.15. That's how you'd answer in context. I ran out of room, so I'm going to leave it like that. That's how you would answer. Nadal's fastest 30% of serves go at least that fast. Not quite as good at Nadal at the serving, apparently. All you know is that the standard deviation of his distribution is 8. His first serves, let's see, 20% of his first serves go less than 100 miles per hour. So 20%, the bottom 20% starts is 100 miles an hour or less. What's his average speed? So now I want you to solve for the mean. What's the mean of this distribution? This is a different player. He's not quite as prolific as Nadal. Vocab?
Yeah, you're all about the vocab.
All about the vocab today, yeah. What do you mean, Emily? Yeah. A couple good vocab terms here and there. So I'll put the mean in the middle, but we don't know what it is. What's the mean equal to? Little mu sign there. I know the standard deviation, that's 8 miles per hour. And then the lower 20%, it's like 100 miles per hour or less. So see if you can come up with that, shade that region, 100 miles per hour or less for that lower 20%. So let's say this is the lower 20. Right, let's say this is 20%. This is 100 miles per hour. So what's the mean? So don't forget z-score formula. X minus the mean divided by standard deviation. Actually, I use mu for this. Mu divided by standard deviation. So you know almost all those, by the way. You know almost all those values. You don't know the mean, but you know what standard deviation is. And what should you put for x in this case? Don't know the mean. We're looking for the mean. What should you put for x? The individual.
Can you just put like anything less than 100 or that?
You should put 100 is the boundary, so let's put 100. So we know x is going to be 100. The only thing we don't have is the z-score, and we don't have the mean. But couldn't you tell me what the z-score was? What's the z-score for the lower 20%? So the z-score for the 20th percentile. Here's we're going to write percentile like this right now. Percentile, how you like that? So I ran out of room. So go to the table. What comes up with the 20%? What's the z-score?
Negative 0.84.
Negative 0.84. Yeah. Or is it 0.84 or 0.83? I don't remember. 0.84.
0.84.
Okay. Yeah. So now you're ready to solve it. Just solve for the mean. You know the z-score. You know the individual. It's 100. And then you know standard deviation. So solve for the mean. So z equals the individual minus the mean divide by standard deviation, which is 8. So what's this guy's mean? Not as good as old Rafi. Few are though. So
106.72.
what's that in favor?
106.72.
106.72. You guys confirm? It's okay. 106.72 miles per hour. mph. So if you're answering in context, I would come back around and conclude like this. This player's average serve speed is 106.72 miles per hour.